Alright, what's up guys? This is Probability by Pitman, Chapter 2, Section 1, Problem number 3. Alright, so suppose 5 dice are rolled. Assume they are fair and the rolls are independent. Calculate the probability of the following events. So P of A is equal to, so exactly 2 sixes. So this is just a clear time to use the binomial distribution because we have independent events, 5 independent events, of which there are 2 events, getting a 6 or not getting a 6. Alright, cool. So now that we had that, let's maybe create a random variable called x, which is the number of sixes. Alright, cool. So P of A is just the same as P of x equals 2, which using a binomial distribution, it should be fairly simple. We have 5 total dice rolls, of which 2 are successes. A success has probably 1/6 since it's rolling a 6 to the second power. 5/6 since the probability of not getting a 6, which is a failure, is 5/6, or the complement of 1/6, 1 minus 1/6 equals 5/6, and we would get 3 of them since there are 2 successes out of 5 total trials, so there has to be 3 failures. Okay, so that's P of A. Let's do P of B. At least 2 sixes. So I think a good way to do this is 1 minus P of x equals 0, minus P of x equals 1, minus P x equals, yeah, just those two. So it's basically anything except where x equals 0 or x equals 1. So it excludes any realities where you only roll 0 sixes or 1 6, but it includes 2 and 2, whether you roll 2 sixes, 3 sixes, 4 sixes, 5 sixes, yeah, out of the 5 total dice rolled. Okay, cool. So it's pretty much the exact same thing. 1 minus 5 choose 0, which is equal to 1. 1 6 to the 0, which is equal to 1, times 5 6 to the 5th power. Minus 5 choose 1, which is equal to 5, times 1 6, 1 power, which is equal to 1 6, and then 5 6 to the 4th power. Let's go ahead and simplify that, I guess. 5 6 to the 5th power minus 5. Okay, so 25, or sorry, 5 6 times 5 6 to the 4th power. So then that's just 1 minus. Oh, so both of these are 5 6 to the 5th power, so it'd just be 1 minus 2 to the 5 6 to the 5th power. Okay, cool. That's our answer for B, P of B. Alright, P of C, at most 2 sixes. So that's pretty much just the complement of what we just did, because at most 2 sixes, oh, actually, no, we have to include the 2. So at most 2 sixes is just, so P of C is equal to P of x equals 0, plus P of x equals 1, plus P of x equals 2. So at most 2 sixes means we have either 0 sixes, 1 sixes, or 2 sixes. Okay, cool. So it's the exact same thing. I'll just speed through real quick. Oh man, it's so tedious. I'll write this. Alright, I'm not going to simplify that, but yeah, that's our answer. Alright, for D, exactly 3 dice show 4 or greater. Okay, so this one is slightly more interesting, I guess. So we'll say y is, our random variable y is the number of numbers 4 or greater. So just to go over that, 4 or greater means 4, 5, 6. That would be considered as a success. And if we have 6 total numbers, that means 3 over 6 equals half. So the probability of a success in one trial is 1/2. So one roll has a half chance of being successful. Cool. Okay, so exactly 3 dice show 4 or greater. So P D is equal to P of y is equal to 3, which is just equal to 5, 3. So we have half, which is the probability of success, which can happen, we want to happen 3 times, then half, which is the complement of half, and we know that will be 2 failures. And that's legit our answer. Coolio. Alright, so E, at least 3 dice show 4 or greater. Okay, so it's really the exact same as we did before. So P of E, at least 4 dice show 3 or greater. So at least 4 dice show 3 or greater, or at least 3 dice. Okay, okay, so 3, 4, 5, 6. Okay, so it's easier to do the complement. So we'll do 1 minus P of y equals 0, minus P of y equals 1, minus P of y equals 3, or at least 3. Okay, okay, so we don't even need this part. Okay, or sorry, why did I write 3? Okay, a little out of it, I guess. Sorry, that should be a 2. Okay, cool. So basically, this includes all realities except where we only get 0 greater than 3, or sorry, 0 greater than 4, 1 greater than 4, or 2 greater than or equal to 4. Yeah. Okay. So it's legit the same thing as before, where it's like 5, 0, half, 0, half, 5, minus 5, 1, half, 1, half, fourth, minus 5, 2, half, 2, half, 3. I guess we can simplify that. So 1 minus half to the fifth, minus 5 times half to the fifth, minus, then 5 choose 2 is just, so 5 times 4, so that's 10. So minus 10 half to the fifth. So then our answer is 1 minus 16 to the half to the fifth. Yeah, alright, cool. I hope that was somewhat helpful.